All right, today's lesson is going to be about solving inequalities. We're going to do both sections of adding and subtracting and multiplying and division, multiplying and dividing. This is really similar to when we,
Where do we get the computers from?
Unkin. Very similar to when we did solving equations, or whatever we did to one side we have to do to the other. It's very similar. The only difference is now we have inequalities, and we're going to have to solve them before we can graph them. So know that very important thing. All right, so when we use solving inequality using the addition, we're going to do the exact same thing, like I said, that we did right before the break, where we, I'm going to go ahead and put my little line here because I have to stay this balanced. And I identify my variable. What am I doing to my variable? What am I doing to my variable right now? Subtracting 5. What is the inverse operation of subtracting 5? So I'm going to add 5 to this side and add 5 to this side. Y'all remember doing this, right? Okay. Then these two will cancel out, leaving me with B. My inequality stays the same because I am not multiplying or dividing by a negative number, so my inequality stays the same. And then what is 4 plus 5? 9. So that is a solution to that problem. Any number, so what this says is any number that is greater than 9 would make this statement true. That's what it's telling me. Any number greater than 9, any number greater than 9 will make this b minus 5 greater than 4 true. So I can check my solution by choosing a number. Give me a number that's greater than 9. 10. If I plug in 10 for my equation, let's see if it makes it true. What is 10 minus 5? 10 minus 5. Is 5 greater than 4? Yes, so it's true. That's me checking my solution. So now I've solved the inequality. Now I've checked my solution, and now I'm going to graph my solution. Mind you, it's graphing the solution. Okay? So I'm going to look at this. B is greater than 9. B is greater than 9. And it does help if you just write the solution next to the graph, so you know that that's what you are graphing. Remembering back yesterday, how do I graph a solution? Go ahead, tell me.
You graph your first number, which is the 9.
Okay, so I'm graphing the number that I'm comparing it to. So I'm going to find 9, positive 9. Now what do I need to do? Go for it. I have to draw an arrow, but before I can draw an arrow, don't I have to do something with this circle? I have to decide something, right? What do I need to decide?
If it's open or closed.
I have to decide if it's going to be an open circle or a closed circle, right? For this particular problem, is it going to be an open circle or a closed circle?
Open.
It's going to be an open because why?
It's just the normal.
It's just a normal. It does not include 9, correct? So now I have to decide which way is my arrow going to go. So I look at 8. Would 8 make this true? Is 8 greater than 9? No. Is 10 greater than 9? So my arrow is going to go to the right. See, and y'all thought solving inequalities was going to be super hard, right? Nope. Nope, not when you have an amazing teacher like me. All right, so the addition property of equality states that if you add the same number to both sides of an inequality, the sides remain equal. That's whatever you do to one side, you got to do to the other. Remember we did that when we were balancing equations. we have to balance inequalities the same way. All right, so if we have to, we're going to be solving inequalities using subtraction. I am going to do just like I did up here. Identify my variable. What am I doing to my variable? What am I doing to my variable? Adding 9. What is the inverse of adding 9? And whatever I do to one side. All right, those cancel out, leaving me with a C. I'm not multiplying or dividing by a negative number, so my inequality stays the same. And what is 17 minus 9? 8. Does everybody agree? All right. So now C can be any number that is less than or equal to 8. So give me a number that is less than or equal to 8. 8. Okay, we'll do 8. So if I put 8 plus 9 needs to be less than or equal to 17. 8 plus 9 is 17 less than or equal to 17? Perfect. I just checked my work. So now I'm going to come down here to graph it. I'm going to go ahead and rewrite my solution that I'm graphing so that my eyes and my brain just focuses on that. First thing that I'm going to do is do what? Find my 8, because that's what I'm comparing a number to. Then I'm going to decide what? Is it open or closed? For this particular one, is it open or closed? Closed, because it can include 8, right? All right, so now I'm going to decide which way my arrow goes. If I plug a 7 in here, is 7 less than or equal to 8? Yes, true or false? Is 9 less than or equal to 8? So then my answer is, my arrow will go to the left. That's a good question. I was just about to say that. The question was, does it matter where my arrow ends? It does not. Because putting the arrow, the tip of the arrow, tells me that it's going to go on that way. If I stop it here, it's fine. If I draw it all the way to here, it's fine. Yes?
If it has the line under it and it can be equal to, can you just leave it draw on the 8, or you have to draw the arrow?
You have to draw the arrow. The only time that you do not draw the arrow is if it says just straight up C equals 8. Not or. That if it just says C is equal to 8, that means the only possible solution is 8. For these particular inequalities, the solution can be any number would make it true. Any number that's less than 8, right? So that's why we have to do the arrow. That was a good question. All right, the subtraction property of equality states that if you subtract the same number to both sides of an inequality, the sides remain equal. So that's with adding and subtracting. Again, we're going to have to remember our adding and subtracting of integers, right? And have to remember those rules because sometimes we might come across those. All right, so multiplication and division of inequalities is very similar to just the same thing that we did with inequalities. There is a set of special rules that we're going to talk about today. So if you're absent tomorrow, you already got the rules, but we will have a set of notes that you're going to glue in that talk about the special rules because there's some special rules. So I'm actually going to kind of put some stars here so I remember that there's some special rules with that. And we'll talk about it after we go through all of them. All right, so we're going to solve an inequality using multiplication. I'm going to do the same thing that I've always done. Keep my balance, identify my variable. What am I doing to my variable? I'm dividing by 4. So the inverse of dividing by 4 is All right, multiplying by 4, multiply by 4. And because these will be reciprocals, they're going to mark out, and I'm going to be left with an A, correct? Would everybody agree? Did I multiply or divide by a negative number? No. To cancel out, I did not, correct? So then my inequality sign is going to stay the same. All right, and then 2 times 4 is 8. So any number that is greater than or equal to 8 would make this solution true, right? All right, we're gonna check our answers. And because we know we're gonna be dividing a number by 4, let's pick an easy number that's gonna divide easily by 4, okay? So I'm just gonna go with 16. Is 16 greater than or equal to 8?
Yes.
All right, so I'm gonna choose that as my, when I check my work. So 16 divided by 4 needs to be greater than or equal to 2. What is 16 divided by 4? 4. Is 4 greater than or equal to 2? Yes? So that is going to be correct. Now I'm going to come down here and I'm going to graph my solution, which is A is greater than or equal to 8. I'm going to find 8 on my number line. Will this be an open circle or a closed circle? Closed circle because it includes 8. Then I go, does 7 make this statement true? Is 7 greater than or equal to 8? No. Does 9 make this statement true? So then my arrow will go to the right. Pretty easy, right? And after yesterday, you're like, yeah, I've got this, right? We're just adding just a little bit to it. All right, the multiplication property of inequality states that if you multiply the same number to both sides of the inequality, the sides remain equal. Whatever you do to one side, you do to the other. All right, now we're gonna do that same thing that we've been doing over and over and over. I'm gonna keep my balance of my inequality. Identify my variable. What am I doing to my variable? By?
5.
Multiplying by 5. What is the inverse of multiplying a number by 5? Dividing by 5. Whatever I do to one side, do to the other. Leaving me with D. Did I multiply or divide by a negative number? No. So my inequality stays the same, and 20 divided by 5 is?
4.
All right. So, checking my work. Give me a number that is less than 4. 2? 2, 3, what? I said 2. I heard 2 first. So, 5 times 2 needs to be less than 20. 5 times 2 is? 10. 10 is less than 20. True or false? True? Perfect. All right, let's do our graphing. And I'm going to be graphing D is less than 4. Find 4 on my number line. Will it be an open or closed circle?
Open.
Open. Will 3, is 3 less than 4?
Yes.
Is 5 less than 4?
No.
So my arrow will go to the left. And then the division property of equality states that if you divide the same number to both sides of an inequality, the sides remain equal. All right, give me just a second to write that down. All right. I'm going to go ahead and now, since we're all in the lesson, I'm going to go ahead and talk to you about the special rules. Okay, the special rules only apply when we are multiplying and dividing. Okay, so I want you to take this and I want you to fold it over. Got it all nice and folded over. Okay, and you're gonna get these glued in, right? Not right now, but here in a second, you're gonna glue these in. All right, so I put that off to the side. So I know you're gonna get this copy of this notes, but I just want you, all I want you to do is focus on watching me as I'm up here talking, okay? All right, so when we solve inequalities, there's special rules. These rules only apply when you are multiplying or dividing by a negative. So only if I am multiplying and dividing by a negative, then I use these special rules. And so when I multiply or divide by a negative number, then the inequality sign is going to be flipped. Okay? So I'm going to have to swap my inequality symbols. So let's talk about these two examples. Again, we're going to talk about this again tomorrow. You're going to get this paper tomorrow. I just want to make sure it's all on the same notes. Okay, so I identify my variable. What am I doing to my variable? I'm multiplying by what? A negative 12. What is the inverse of multiplying by a negative 12? So I'm going to divide by negative 12. Divide by negative 12. Everybody with me so far? Yes? Okay, now I'm going to rewrite it. So I'm going to leave me with G. Did I multiply or divide by a negative number? So then I have to use my special rules. Because I multiplied or divided by a negative number, my inequality sign now is going to flip. So everybody see that? It flipped out. It says, oh my gosh, negative numbers, I'm going to flip out. Then I still do the same thing. So 48 divided by negative 12 is going to give me negative 4. Would everybody agree? Yes? Okay. So we're going to check it. I need a number that is greater than negative 4. Give me a number that is greater than negative 4. Negative 2? Yeah, that'll work. So let's check my work. I'm going to plug in negative 12 times negative 2. I only flip it in my solution. So I'm going to remember, because I'm checking it at this. Negative 12 times negative 2 is? Negative or positive?
Positive.
Positive 24. Is positive 24 less than 48?
Yes.
Perfect. Then my solution is right. I'm going to graph it. Now again, this is where I told you to rewrite just the solution is going to come in handy. So I'm going to write this. I'm graphing. G needs to be greater than negative 4. I do negative 4. I do one below it and one above it. Will this be an open circle or a closed circle? Open or closed? Yeah. And so is negative 3 less than negative 4?
Yes.
Yes. Is negative 5 less than negative 4? No? So which way is it going to go? To the what? To the left? Very good. All right. And then we'll do this other one tomorrow. I just wanted to have these on the notes.